Welcome to True Projects. In this video, we are going to explain about the project that is a novel deep learning architecture optimization for multiclass classification of Alzheimer's disease level. Before getting into the execution, first let us understand what is the project about. Alzheimer's disease. It's a condition that slowly affects a person's brain. Because of that, person loses his memory, he will have confusion and also trouble with the language, and it is a progressive disease, that is progressive neurodegenerative disorder, means it gets worse even over the time, and the symptoms tend to worsen as the disease advances. One of the most challenging aspects of Alzheimer's is that its early signs are often subtle, and they are sometimes confused with the normal age people. So this is where detecting the disease early, especially at the time of mild cognitive impairment stage, becomes very important. If we can detect at this stage, doctors can intervene with the treatments and also strategies that can slow down or even prevent the disease from progressing further. So, magnetic resonance images, that we call it as MRI. These images play a crucial role in this process. It is non-invasive scan that doesn't require any surgery or needles, and it can give doctors a detailed look at the brain. In Alzheimer's patients, MRIs can help in identifying brain abnormalities that are characteristic of the disease, like shrinking of certain brain areas. This is a key tool in diagnosing Alzheimer's and tracking how the disease progresses over the time. So, analyzing this Alzheimer's disease from MRI images can be a real challenge for doctors because it is not only time consuming but it also requires a lot of manual effort and expertise. Plus, there are always a chance of human error, and different doctors might interpret the images in slight different ways, leading to variability. That's where artificial intelligence comes into the picture. So, here where artificial comes into the picture, artificial intelligence, particularly convolutional neural networks, which are type of machine learning deep learning models designed to analyze images. These models are really good at spotting patterns, and they can help doctors to classify and segment MRI images more efficiently. But there are problems with this CNNs. That is, for one, they can easily overfit, meaning they get too tailored to the specific examples they have been trained on and struggle with the new data. Also, the availability of the label data, that we call as MRI scans with clear, accurate diagnosis, is often limited, which makes training these models more challenging. The high similarity between different stages of Alzheimer's or between Alzheimer's and the other conditions can be confusing these models as well. On top of that, these CNNs often need a lot of manual tweaking to get everything just right, like adjusting the number of layers, the learning rate, and the other factors, which adds the difficulty too. These challenges make it harder for AI models to detect Alzheimer's reliability in the early stages. And that's something we need to address to make technology more effective and useful for doctors. So, to overcome with all these issues, this project is designed to automatically classify the severity of Alzheimer's disease using MRI scans. So, the idea is to make the process faster and more efficient by using convolutional neural network, which is optimized by particles from optimization. So, here not just a standard CNN model is taken. So we have taken it to step further, that is by optimizing the model with a technique called PSO. So what this PSO does it is that it helps to fine tune a bunch of important settings that we call as hyperparameters, which are including convolution layers, filters, dropout rates, learning rates, and batch sizes. All this comes under hyperparameters of CNN model. So convolution layers are the model learn different features from the image and number of filters which determine how much the detail image looks at. Dropout rate is to prevent overfitting, learning rate which controls how quickly the model learns, and we do have some optimizers that will be used in this project. So by tweaking all the settings, PSO makes sure that model performs it at best while handling challenges like a limited amount of label data for risk of overfitting. Essentially, it helps the system learn in the most efficient way possible without making mistakes due to much training or small data set. So to make sure the model trains efficiently and stays stable, here in the PSO we have taken multiple optimizers, that are stochastic gradient descent and the NADM. These optimizers built in the PSO optimization process, which means they help to adjust the model learnings in the best possible way. SGD, that is stochastic gradient descent, is simple yet effective method, updating the model weights based on gradient of the error. And NADM. It is, on the other hand, combines the strengths of Adam that we call as an adaptive optimizer with Nesterov momentum, which can speed up the learning process and make it more effective. So the combination of these optimizers with PSO ensures that CNN model is both lightweight, not too computationally heavy, and powerful enough to accurately classify the severity of Alzheimer's. This not only makes the diagnosis process faster but also reduces the burden on doctors, allowing them to make quicker decisions by identifying Alzheimer's early. The system plays a crucial role in disease management and prevention, which could ultimately improve patient outcomes. And further on, to improve the classification accuracy, to further improve the accuracy of the classification models, here we are incorporating multiple models. So we have used NASNet mobile model, which is more advanced deep learning model, and we have also considered an ensemble model, that is combination of multiple models, that is CNN with NASNet. So this approach helps us to enhance the accuracy in determining the severity of Alzheimer's disease, giving us even better results. And we have also added in detection part. So for that we have incorporated YOLO model, that is you only look once family for object detection models. What this does is it allows the system to not only classify the brain scans, that is MRI scans, but it also pinpoints and identifies specific abnormalities or the areas of the concern within the scan. So this gives us more detailed view, that is through the analysis of the images, which is really important when detecting early signs of Alzheimer's. And coming to the part of front end, so we have built front end using Flash framework. This is application which includes user authentication. This also includes user authentication too, ensuring that only authorized users can access it, which is essential for privacy and also security. It also makes the system more interactive and accessible for clinicians, allowing them to easily test and use the system in their practice. So this is overview of the project. Now moving on to the flow of work. Coming to the implementation, we have followed the steps mentioned in the flow of work. So to implement classification, that is to classify just the brain MRI images, we have followed these steps. Set of steps for classification, we have followed the other set of steps for detection of the Alzheimer's disease. Now let's understand what steps that we have followed. So first what we have done is we have imported all the necessary libraries related for image classification such as TensorFlow, Keras, and others. We have also imported libraries for model building purpose. Then comes the exploratory data analysis part. So in this step, the data set, that is MRI images of Alzheimer's patients, are explored to understand its structure and the images to be processed. Then comes data augmentation part to improve the model generalization. So we have adjusted the image size for consistency, that we call it as rescaling, and then we have disordered the images for better robustness, that we call it as shear transformation. And then we have added zooming effects for model training, that we call as zooming the image. And we have also flipped the images horizontally. So this flipping images to this is done to increase the diversity. Coming to reshaping, so this ensures that all the images have the same shape to input the model. Then comes defining the early stopping to avoid underfitting or overfitting. So here this technique is used to halt the training if the model starts overfitting or underfitting, ensuring it's a better performance. Then comes calling the model. So this step involves defining and initializing the convolutional neural network model, that is CNN model. Then comes building and training. So the CNN model is constructed and trained using the prepared data set. And the best performing model is saved for future use in the classification for classifying abnormalities. Then comes the detection part. So similar to classification, here for detection also we will be inputting required libraries, that are OpenCV and YOLO required libraries. And then we will be loading the data set. After loading, we will be visualizing the data set to understand its contents. Then comes image processing part, where we convert image to blob format, so that the image is in a format suitable for YOLO processing. Then comes defining the class. So this is specifying the classes, that is the abnormalities that the model will detect. Then comes declaring the bounding boxes. So it is defining the area in the image where an object is detected, that is where an Alzheimer is detected. Then comes converting the array to a NumPy array. So here we prepare the image for data processing, that is converting an image array to a NumPy array. After that, we load all the YOLO model architecture. After that, we focus on the layers that generate the object detection results. Then comes the image processing part where we attach relevant annotations to the image. After that, we convert the images which are in the BGR format to the RGB so that the image color format is proper for the processing purpose. Then we create the mask. That means we generate mask for object detection. Then comes resizing the image. So we resize the image to fit the model input size. Then comes data augmentation. So we introduce randomness in the image to avoid overfitting. And also we rotate the image, that is we apply rotation for availability, sorry, that is variability. After that, we apply additional transformations for better training. Then comes processing data based on YOLO family. So this step involves preparing the data in the format that YOLO can process. Then comes building the model. So here we construct the YOLO based detection model for abnormality detection. Then comes training the part. So here we train the model on augmented data set. After that, the best version of the YOLO, which achieves the highest performance, will be saved for further detection. So this is how we have done classification and detection. Coming to the part of front end. So we have developed user interface which is built using Flash framework. So this allows users to interact with the system via a web-based interface. Registration and login functionalities are supported by SQLite for the data storage. And in the front end, users they will be able to upload images for classification on also detection purpose. The uploaded image of the users will be pre-processed at the backend that will be fed with the train model. Finally, outcome will be displayed through the front end of the application. So this is how we have implemented the project. Now coming to the algorithms used, these are the algorithms used in this project. So these two are the proposed models and these both are the extension models. And for detection purpose, we have used these three models that are different versions of the YOLO, that are YOLO V5X6, YOLO V8, and YOLO V9. And to implement this project, we need basic requirements which are hardware and software. Coming to hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB, and hard disk of 25 GB and above. Coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework Jupyter Notebook, database SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So these are the requirements that we need. So now we are supposed to execute. To execute, open the code folder that contains source code file. So let's open the code folder. So these are the source code files. Let us understand each of them, how will be used in this project. So in this, we have the data set. So here we have Alzheimer's in different stages, that is mild stage, moderate stage, non-demented stage, and mild demented stage. Let's see what are the images we have. So here in the mild folder, these are the brain MRI images where a person has mild dementia, that is mild Alzheimer's. Dementia is nothing but Alzheimer's here. Now let's get back. So here in this folder, we have MRI images where the person has dementia in the moderate stage. And here we have brain images where there is no dementia. And here in the last folder, we have very mild dementia images. That means person has very mild Alzheimer's. Let's get back. And all these images are split into two subfolders. One is train and the other one is valid. Here, images which are in train folder are used to train the models and images which are in the validation folder are used to evaluate the models. So this is about the data set. And these images are used for classification purpose, not for detection. These images are just used for the classification of the Alzheimer's disease. Now let's get back. Here in the sample folder, we have two subfolders. One is classification and the detection. Images which are in classification, we will be using them in the front end for classifying Alzheimer's. And images which are in the detection folder, we will be using them for detection purpose in the front end. Let's get back. And this is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files which are important for the visual appeal. Then we have templates folder. This folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here we have images in YOLO V5, YOLO V8, and YOLO V9. Let us open the YOLO V5 folder. So here images are split into train and test. Let's open the train folder. Here we have two more subfolders. One is images and the other one is labels. Let us open images folder. So these are the images we have that are used to train the YOLO V5 model for detecting the Alzheimer's. So here these images are used to train the YOLO V5 model for detection purpose. So these images are used for detection purpose. So for these images, we have annotations in the label folder. So label folder, here in the label folder, we have annotations and object locations in these files. Let's open them. Here each label file, it is correspondent to image file. It is each label file is correspondent to image file. It provides object locations and classes within the image. So for example, this first image, first annotation file, it corresponds to the first image in the image folder. For the second image, we do have annotation file. So let's open it. So this is the second annotation file for the second image. Accordingly, for all the images which are in the train folder, that is all 800 images, we have annotations in the label folder. Annotations are nothing but in the image where that particular disease is. So we will be pinpointing the disease on the image, right? So that location will be there in this label files. So let's open the file for example. So here this line represents a detected object. This is the object class index and this is followed by its bounding box coordinates. This is the x limit, this is the y limit, this is the width and this is the height. So when we detect an object in the front end there, a bounding box will be drawn around the disease. So that locations are these points. Now let's close this. So similarly, we will be having in all these files too. Let's get back. So images which are in train folder will be used to train the YOLO V5 model and images which are in the test folder will be used to evaluate this YOLO V5 model. Accordingly, we have same images in YOLO V8 and YOLO V9 also, but they are annotated differently because each YOLO version requires its own specific type of image annotation for training and also for testing purpose. Having separate folders helps keeping the dataset organized, ensures that each YOLO version receives the correct annotations it needs to function properly. So this is about the data set. And now here in the app.py file, this .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And here we have model files. So these are the model files which contain the algorithm information and that will be loaded into the project code during runtime of the application. So this all .hy files are the model folders, model files. And these two files are the notebook files, I mean Jupyter notebook files, which contain the combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. So here in this Jupyter notebook file, that is classification Jupyter notebook file, we will be training all the images of this folder, that is the dataset folder, just for classifying the Alzheimer's. So here we will be training the models for classification purpose. And in this Jupyter notebook file, we will be training the models for detection purpose. And this is the signup.db file. This file is a database file which is used to store the user information. So this is all about the code folder. Now let us execute. So copy the path of the code folder from the address bar of the file explorer. I'm copying the path. So now open the Anaconda prompt. Here it has been opened. Give the command cd, give the space, paste the copied path. Now click on enter. Here if you observe, current directory is changed to the code folders path. Now we are supposed to compile app.py file. So give the command python space app.py and now click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will load the application locally at the default address, which is the localhost and the port. Just wait for a while, it is being loaded. So this is the localhost and this is the port. Now copy this local link provided by the Flask framework and paste it in any web browser. I'm copying the link. I prefer Google Chrome, so I will paste it in that. Paste the link here, click on enter. So this is the web page of the project which is developed using Flask framework. So we need to get registered first. Click on register and enter all the registration details if you are registering newly. I have already registered, so I'll directly sign in. Click on sign in. So give your username and the password. Click on login. We have logged in successfully and we are redirected to classification page of the project. So here we will be doing classification and detection individually. So first let's do classification. So under Alzheimer's disease, click on classification. So here you can see a choose file button, right? We need to click on that for uploading the MRI images. Click on choose file, open the sample folder. As we're doing classification, open classification folder. So now let's upload images from this mild demented folder and let's see whether application will correctly predict it or not. So open it. So these are the images. Now let's select this, click on open. It has been loaded. Now click on upload. So this given image, it will be pre-processed at the backend and then it will be fed with the train model. Train model will be giving us the image. So this is the uploaded image and here we got the prediction that patient has mild dementia. So the patient has mild dementia based on the uploaded image. This is the brain MRI image. Based on that, here it has been classified as he has mild Alzheimer's. Now let's try uploading some more images. Click on choose file. Let's upload this one. Click on open and now upload it. So here also we got the same prediction that patient has mild dementia. Now let's check with the other cases. Click on choose file. So now let's upload images from this folder. So let's upload this one. Click on open and now upload it. Here we got the prediction that patient has moderate dementia. So based on the uploaded image, this is the uploaded brain MRI. And here we got the prediction that patient has moderate dementia. Now let's check with the one more image of the same case. So let's upload this one. This one let's upload. Click on open and now upload it. So here we got the prediction that patient has moderate dementia. This is the image we have uploaded and here we have the prediction. Now let's upload from the other folders. Click on choose file. So get back. Let's upload images from this folder. Select it, open it and click on open. So here we got the prediction. This is the uploaded image and here we got the prediction that patient has no dementia. That means patient is not having any Alzheimer's disease. He can remember everything. So he's in the non-demented stage. That means patient has no Alzheimer's disease. Click on classification. Click on choose file. So let's upload this image. Upload it. So here we got the prediction that patient has no dementia. Now let's check with the other one. Click on choose file. So let's upload images from the last folder. Let us upload this one. Click on open. It has been loaded. Now click on upload. So here we got the prediction that patient has very mild dementia. That means he has very little Alzheimer's where he is in the initial stage. He's in the starting stage. So treatment has to be taken at this stage so that he can remember everything. So now let's do the detection. Click on detection. As of now, we have done classification. Now we will be doing detection where we will be identifying where that Alzheimer's is. I mean, which point of brain has been affected by that Alzheimer's has occurred to him. Alzheimer's disease is affected by the person. Let's click on choose file. So get back to sample folder, open detection. So let's upload this image. Click on open and now upload it. So here also image will be pre-processed at the backend and then train model will be giving us the detection. So here you can observe that mild dementia has been detected and a blue color bounding box is drawn around it with the 0.71 probability score. It is the confidence level that how accurate the detection is in detecting this particular class, that is mild dementia. Let's get back. Click on choose file. Let us upload some more. So now let's upload this image. Click on open and now upload it. It's being loaded. So here we got the prediction that moderate dementia has been detected in sky blue color, ocean blue color bounding box. You can observe, right, with the 0.991 probability score. Let us upload some more. So now let's upload this one. Click on open and now upload it. So here you can observe that there is no dementia. That means person has no Alzheimer's disease with the 0.91 probability score given by the application. Let us upload last image for this. project. So let's upload this image. Click on open and now upload it. So here we got the prediction, that is the detection that while dementia has been detected. You can see a bounding box is drawn around it. Now let's get back. So this is how you need to execute. Now let's check with the graphs. Click on graph. So here the first graph which we have is the accuracy comparison graph. Here on x-axis we have accuracy score and on y-axis we have all the algorithms that are trained on the data set, that is brain MRIs, to classify the Alzheimer's. It is at which stage? And this is the precision score comparison graph. This is the recall score. This is F1 score comparison graph. And here we have precision recall curve graph. This is the precision confidence curve graph. This is the recall curve graph and this is F1 confidence graph. And this is the confusion matrix. And this is precision score. This is recall score. This is mean average precision. So mean average precision, precision and recall are used to evaluate all the detection models, and accuracy, precision, recall are used to evaluate the classification models. So these are the models trained for detecting the Alzheimer's. Now let's click on log out. In this way, just by giving image to the application, it will classify whether the person has dementia or not, that is the Alzheimer's or not. If the person has Alzheimer's, it will detect at which stage it is, and it will also be classified. This is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.